Welcome back, ladies and gentlemen. Big jump in the book, right? We're jumping a few units right up to rational expressions, and there's a reason. And if you look really close so far, like look at that. That looks like a factor, doesn't it? X plus 7 over x plus 8. And then if we take a quick skim ahead, look, that looks like polynomials. Those look like polynomials that can be factored, doesn't it? Okay, so now you can see why we're making this big jump right away. We've just finished our factoring unit. We might as well keep it fresh in our brain and do one of the other units that involves factoring. And like I said, it's going to come into play a little bit, right? So rational expressions and equations, lesson 1, simplifying rational expressions, part 1. So there's 2 parts. Okay? A rational number is any number that can be written as a fraction, if you remember from one of our previous units. So 4 over 7 is a rational number. We can turn this into an expression by simply adding in some variables. So this is a rational expression. It's 2 expressions that can be written as a fraction, so it's a rational expression. Okay. Single variable, what's it say here? It says a single variable rational expression is an algebraic fraction in one variable which the numerator and denominator are both polynomials. Okay. This is a rational expression. There's just x's involved. This is a rational expression. There's just y's involved. This is actually not factorable, but it could be factorable. So in this unit, we're going to learn how to add, subtract, multiply, and divide rational expressions. And if we get a chance, we'll do some problem solving as well. Okay. Like I alluded before, though, the key to success in operating with rational expressions is the ability to factor polynomials. I told you when we were doing the polynomials unit that factoring polynomials is going to come into play in other units. Remember, first step in any factoring question, greatest common factor. Then maybe you only have 2 terms, maybe it's difference of squares. After that, if you can factor by inspection and or factor by decomposition, that's great, that's the next step. And then of course, if there's 4 terms, you would factor by grouping. Okay, that's all of our factoring steps. The next couple of pages, which I'm not going to go into, I'm going to show you real quick, but the next couple of pages are some investigations that show that one polynomial expression or one rational expression is equal to another one. And I'm just going to show you. I'll do this in a minute, but I'm going to show you. So that's what this investigation goes through. The next investigation goes through something similar. The next investigation goes through something similar and adds in, well, something called a non-permissible value, or what values make the expression not defined, which I'll talk about as well. But I'm going to kind of simplify this a little bit and take out probably, well, I'm not going to do these 2 pages, but I'll show you essentially what it all boils down to. So basically, this table is going to show us or prove to us that this is equal to this by substituting in values and calculating. But I can very simply show you by saying, hey, you know what? We can all do this. We can all take this fraction and do what with it? Hopefully in your mind, you're saying, well, we can reduce that fraction. We can reduce that fraction to 2 over 3. Why? Because 6 and 3 or 6 and 9 both divide by 3. It's called reducing a fraction. Well, where does that kind of come from? 6 over 9 is also equal to 2 times 3 over 9 is also 3 times 3. Well, look at that. What is 3 over 3? That's 1. Those are going to cancel, leaving us with 2 over 3. That same idea with rational numbers or simplifying rational numbers can be used with simplifying rational expressions. So really, if we take this expression, 2x plus 2 and x squared plus 3x plus 2, and we factor the top and bottom, on the top we're going to get 2x plus 1, greatest common factor of 2. On the bottom, I'm looking for two numbers that multiply together to give 2, add together to give 3, factor by inspection. This is going to be x plus 2 and x plus 3. No, not 3, 1. X plus 1. Well, look, x plus 1 over x plus 1, these are going to cancel out. That's going to leave us 2 over x plus 2, which is exactly the same as the other one that they're trying to prove. Okay? So just like simplifying a fraction, a rational number, we can simplify a rational expression if we can cancel factors like this. Okay, so if we can cancel factors like this, we can simplify that expression, which is basically what this whole unit is going to kind of be about. We're going to try and simplify some rational expressions. The key thing to remember, though, is that we're canceling factors. So this x plus 1 is a factor. This x plus 1 is a factor. These are whole entire things. This will cancel with this. Unlike, well, hey, we can't say that both of these have a 2 in it, so we're going to cancel those 2's. We can't do that because of this plus sign, okay? This is a thing. The biggest thing I can tell you that's going to help is once you create these factors, encase them in their brackets that are supposed to be there, but sometimes we never write. And then anything within a bracket, you can't individually cancel parts of it out, okay? Big thing to remember. Now here's another question for you, which is going to lead us into our next example. Let's say we're looking at this expression, 2 over x. What happens if x is equal to 0? This becomes 2 over 0, but 2 divided by 0 is undefined. Okay? So really, this expression would be valid as long as x does not equal 0. Okay? This is called a non-permissible value, or a value that makes the expression undefined. And this looks kind of similar to when we were solving those rational or those factoring questions back in lesson 6 of the factoring unit. Okay, so these restrictions, they're called restrictions or non-permissible values or values that make the expression undefined. These have to be stated at the beginning of a question. If we don't state those at the beginning of a question, then really there's going to be some issues that come along with it. Okay, so we always have to make sure that we state those non-permissible values at the beginning of a question. So right here, although these two things are equal because of the canceling, I have to state my restrictions here. So here, my restriction would actually be x cannot equal -2 or -1. Because if I put in -2, this is going to equal 0. If I put in -1, this part is equal to 0. And that's going to make our expression undefined. This will become more clear as we work along. Okay? So that is essentially everything that they're kind of getting across in these investigations, these first two investigations of this lesson. Okay? Non-permissible values and restrictions. If it's in the denominator, we have to define those restrictions. Okay? So let's work through a couple of examples, and then hopefully it kind of all comes together and makes sense. Okay? So let's go way over to example number 1. Express in simplest form, stating the non-permissible values of the variable. I always try to do the non-permissible values first because they tend to get forgotten. Now, the problem with doing the non-permissibles first is that you actually have to factor your denominators. But you have to factor your denominators eventually anyway. So it really doesn't matter. So it's totally up to you. I try to do these first also because as soon as I simplify and cancel some factors, then I might lose 1 or 2, but we can't lose those. They have to be included, okay? So let's begin. 12x squared over 2x. My first step is I'm going to say, well, my non-permissible value means that this 2x cannot equal 0. So I'm going to solve for that x. I'm going to divide by 2, divide by 2. X cannot equal 0 divided by 2 is 0. There is my lone non-permissible value. There's only one because there's only one x in the denominator. Now I can go on and start my simplification. Well, I can see that both 12 and 2 divide by 2. That's going to give me 6x squared all over x. And that this x squared and x are going to simplify. This will cancel out. This x on the denominator will cancel out, and it'll cancel with one of these x's. So essentially my final answer is 6x, as long as x does not equal 0. Seems not too bad, right? Question B, a plus 1 times a minus 6 all over a plus 7 times a plus 1. Now this is a perfect question to do my non-permissibles first because my denominator is already factored. Now remember, non-permissibles only require us to look at the denominator. The numerator can be 0. That just means our answer would be 0, but the denominator cannot be 0. So what I think is, or the process I go through in my mind is that this, because of our zero product law from a previous unit, remember our zero product law, this cannot equal 0. A plus 7 cannot equal 0. And I solve. I'm going to subtract 7. A cannot equal -7. There's one non-permissible. And then I do the same thing for this factor, a plus 1. A plus 1 cannot equal 0. Subtract 1. A cannot equal -1. There's my other non-permissible value. And as soon as you have those, you're done and you can move on. So now I get to erase that. There's my non-permissible values, -7 and -1. Now I can start to simplify. Remember, I'm going to cancel factors. I'm going to cancel this entire bracket with this entire bracket. These will cancel. These will disappear. These are things. I cannot cancel these a's because they're encased in their own brackets. They're parts of other things. So that leaves me a minus 6 over a plus 7. There's my final simplified answer. Now, that's beautiful. Both a and b, there's no factoring that needs to happen. But with question C and D, you can see clearly I'm going to need to factor my denominator here. I'm going to need to factor my denominator here. I'm even going to need to factor my numerator up here. That's why it's so important, or it was so important, that we understand or understood how to factor polynomials in the previous unit. So let's do question C. Before we can do our non-permissible values, I need to determine what those factors are. So I need to factor y squared minus y minus 20. This question can be factored by inspection. Two numbers that multiply together to give -20, add together to give -1, whatever process you would go through, even if you use decomposition. Okay, this is going to factor to, here's my numerator, y plus 4 all over y minus 5, y plus 4. Okay, so all I've done is factored the denominator. Now I can do my non-permissible values. And I'll go like this. I'll do them in purple. Non-permissible value for y minus 5. There's my non-permissible values. Y minus 5 cannot equal 0. Plus 5, plus 5. Y cannot equal 5. Now, eventually, you should be able to do your non-permissible values fairly quickly once you've got this factored. And then I'll do a darker purple for the y plus 4. Y plus 4 cannot equal 0. Minus 4, minus 4. Y cannot equal -4. There's your two non-permissible values, 5 and -4. Now I can go on with the simplification process. And I can see that this should be in a bracket. Whoops. this should be in a bracket. And this y plus 4 is going to cancel with this y plus 4. But remember, it's a division. So y plus 4 divided by y plus 4, remember, that's going to leave me 1. But these will cancel. That will leave me with 1 over y minus 5. And I'm going to put that in brackets because I'm trying to remember to do that. And that would be complete. Question D. X squared plus 11x plus 28 over x squared minus 49. Again, the numerator is going to eventually need to be factored, but before I do my non-permissible values, I need my denominator to be factored, so I might as well just factor everything right now. On my numerator, I think, well, two numbers that multiply together to give 28, add together to give 11. Those numbers are 7 and 4. X plus 7, x plus 4. In my denominator, this is a perfect square. This is a perfect square separated by a minus. This is difference of squares. This is going to factor to x plus 7, x minus 7. Done. That's factored. Now I'm going to do my non-permissibles. My non-permissible values, or the factors, are the values that make the expression undefined. Okay, different terminology. I'm going to go x plus 7, just my denominator, equals 0, cannot equal 0. X cannot equal negative 7. And I'm going to go x minus 7 cannot equal 0. I'm going to add 7. X cannot equal 7. There's my two non-permissible values, 7 and negative 7. Okay. These non-permissible values come into play when we do solving, because sometimes when we solve these things, some values come up as solutions, but they actually are non-permissible values and can't be used. Okay. Now I can go back to my question and I can do some canceling. X plus 7 is going to cancel with x plus 7. That's going to leave me with x plus 4 over x minus 7. And again, I'm going to put these in brackets because I'm trying to remember to do that. Okay. So factor and cancel. Factor and cancel, just like reducing a fraction. Just like reducing a fraction. Okay. That's it for some examples. If you have questions, you'll bring them up in class. You'll check Scholantis for the work that needs to be completed. And we will see you next time.